Hi, I am Q, as mentioned. I've been using Python for several years, and I've seen how code reviews are handled differently in companies and also on open source projects. So I just want to talk a little bit about how you can save time while doing them yourself. So as the saying goes, the best code is no code at all. This naturally means the rest of your code, which is about all of it, is not the best code. Code review helps us to deal with this situation. And I believe the same principle applies to code reviews. The best code reviewing is when you're not doing it. So naturally, this talk is about how to most effectively be lazy. So we'll briefly cover what we're trying to gain from code review, what tools are available for Python and what we should actually use, how these tools can be used, and how we should actually integrate them into our workflows most effectively. So let's briefly cover what we are actually trying to automate. What do we gain from code review? We want to be able to catch bugs, reduce security vulnerabilities, make the code more maintainable, and keep it as an opportunity to teach and learn things. All of these aspects, save for the last, can be partially automated. What do we gain from automating these things? Well, it reduces the total time that everyone spends reviewing code. It is not a joke that at one point I was spending more time reviewing code than actually writing code. We gain the ability to spot things in our own code before we actually put it up for review. There's less nitpicking and conflicts of opinion in general. And overall, you save time to focus on high-level concerns that current tooling cannot consider intelligently, such as architectural issues or project-specific knowledge. What could we potentially lose when we're automating some parts of code review? Well, some tools require much more setup and careful introduction to the code base than others, and this by itself can take up a lot of time. In addition, when a tool is improperly configured, it can have excessive output and false positives, leading them to be ignored or just hated. This results in time being lost maintaining the tool. We need to make sure that we're using the right tools for the situation, properly configured and strongly integrated within everyone's workflows to gain the benefits that are on offer. Let's start off by looking at the tools that are available for Python. At the most basic and least important level is the formatting of the code. I think this is quite important, but not as important as real bugs and security vulnerabilities. I'm not going to talk about why I think it's important, but let's jump into how to do it. As recently as last year, I would have talked about tools like PyCodeStyle or Flake8 or Pylint that check against PEP8 and then output errors, which you then read, and then you edit your code so that the errors go away. These tools are literally evil. Do not use them to check your code formatting. They are literally evil because of the massive back and forth that they cause. So when you run the tool, it outputs errors. You have to find where they are in your code base. You have to fix them. You have to run the tool again to make sure that they've gone away. Overall, you don't feel like you're actually getting anything done. They are literally evil because of the massive amount of configurability that they can have. There's a lot of options on exactly how you want your code base to look. What you want to use instead is Black, ISO, and Doc Formatter. Black formats your code for you. That is, it rewrites your code to fit the standard code style, that is standard. One sensible standard for every code base, every project, no matter where you are or who you're working with. No more adapting your work on open source projects or when you change teams. No more nitpicking or pull requests, ever. No more thinking about code formatting at all, ever. Black compromises in giving you two choices in two areas only, the line length and whether you want to turn strings into double quotes. And even the last one was actually quite a battle before they implemented it. It is great, everyone should use it. So the next tool is ISO. ISO formats your imports and actually gives you some choice on how you want to do it. And then the last tool, which is far less used, is doc formatter, which is a bit fiddly. It formats your doc strings, and you do have to be a bit careful with it. It can mess up your doc strings at first, or produce results that you might not be expecting. Overall, black is a no-brainer. It's fast to implement, it's fast to use, and it comes in peace, even if it will nuke your entire code base at first. I would recommend ISO, but maybe not doc formatter. So what's left when it comes to code style? Well, you do have other non-Python files in your code base, and editor config will let you define some basic standards for those files as well. That can be automatically applied when you're editing or saving your files. For example, okay, so this might be quite hard to read on this screen, but this editor config file says that for every file, I want the end of line to be the Linux new line. I want to trim trailing white spaces and have a final new line at the end of the file. And for HTML files, I want indent size to be 2. So your editor can automatically pick this up. Many IDEs like PyCharm will just read the editor config file and automatically start applying it. Others like Atom or Sublime Text or VS Code have plugins that you can use. Another thing that you might want to consider is spell checking. Perfect spelling would be nice, but I don't see actual mandatory spell checking actually going down well with any team, if for no other reason other than there would be far too many false positives for it to actually be worthwhile. For example, in this example, there's a variable which is use LXML library, and you set that to true. LXML is the name of the library, it's perfectly valid, but PyCharm spell checker underlines it. But if your IDE does support it, it's quite natural to be using spell checking to the point where it's strange that I'm even saying it. If it doesn't, you might want to add it into your text editor. How can we catch bugs? Automated tools catch bugs by looking for known code smells, known dangerous code patterns, and code that is known to unintuitively cause unintended results. Unlike black, unfortunately, the tools that I'll talk about here are not revolutionary, but they're already quite well known. Nevertheless, I think some of them are more useful, easier to use, or faster to implement than others. PyFlakes is a great tool. PyFlakes checks each file individually, which means it runs quite fast. It aims to never complain about style or give you false positives, which means it doesn't annoy you. So these two things make it easy to use this tool everywhere, really, for every project. So let's talk about this contrived one-line example that I have here. Here there's an assert statement which is checking whether 1 equals 2. And if it is, it will give an error. But the person who wrote it put the two parts in parentheses. This specific example, I probably would not have picked up in code review, because it wouldn't have actually crossed my mind before. But PyFlakes complains that this assertion will always be true, because it's actually a tuple, and that evaluates to true. So McCabe is a tool to measure the complexity of your code by measuring the number of different independent paths that your function could take. Personally, I don't think it's particularly useful because you can generally tell when something is complicated. It might be useful to set a very large upper limit, but it's too easy to get around this without properly refactoring the code. So while I think it's interesting, I think it has limited utility for actual projects. So Pylint is quite a comprehensive tool. It covers code style, conventions, warnings, errors, unused and duplicated code, and probably many other things that I'm not even aware of. It's an order of magnitude slower than PyFlakes, not only because it covers a lot more things, but also because it follows through the code in the entire project. So it looks at the imports and looks at those files, and this just means that it has more things to do. In my opinion, Pylint is far too configurable. Usually it produces far too many false positives, which is why it's further down on my list of suggestions. So type hints in Python are exactly that. They're optional hints. They are very helpful in improving code completion and serve as documentation. The bigger the project is, the more useful they will become. MyPy and Pyre are the two biggest tools to actually verify the type annotations that you have in your code base. How can we check security automatically? Well, we can certainly make an attempt at it. So Bandit is a tool that can point out security issues that you might not even be aware of. For example, this contrived one-line example, which does nothing except import LXML. If you run Bandit on this, it will output raising an issue that LXML is vulnerable if you pass in untrusted XML data. And it gives you a suggestion to replace it with a diffused XML package. This is, you might not even be aware that this is a security issue. So Bandit can be useful in that regard. On the other hand, Bandit can also have many false positives. So this two-line contrived example, where we import random, call random, and do literally nothing else. Bandit will complain that using the random library is not suitable for security cryptographic purposes. Of course, we're not doing anything like that here. So there are false positives that you might want to disable with this tool. Checking security of dependencies can be a bit of a minefield. So you could have a lot of dependencies, and keeping track of them can be difficult. In general, I would suggest keeping dependencies up to date at all times. Update them when you're adding a new one. Update them when you want to use a particular dependency. Update them just for no good reason at all. Safety, or PIPM check, is a good tool to check for known security vulnerabilities in your project. So when a security vulnerability is published, these two tools can check your list of dependencies against the published list. So in this contrived example where I run pipm check, I installed Django 2.2.1 deliberately, of course. Pipm check complains that there's a security issue in this version of Django where a HTTP request is not redirected to HTTPS. I just cut off some of the text. So this can be useful. It's incredibly easy to use. There's basically no false positives. So there's basically no reason not to be using this tool. You can even fail your entire continuous integration pipeline, forcing you to fix the security vulnerability. I think that's a great idea. You might not. Another alternative is GitHub's Dependabot, which can create pull requests on your project. This might be useful for an open source project, for example. So you can point out out-of-date dependencies and also tag which ones security issues. If you have continuous integration set up, if it passes, you can just merge it in and you're sorted. The only problem with this might be is that you can say no to the pull request or ignore it. And I just don't think that's a good idea. So there's a few things that I haven't covered in the list of tools that you can use, but I'll briefly mention them. I'm not talking about code test coverage at all, because unless you intend to require strictly increasing test coverage, it's not useful day-to-day at all, really, in any way, shape, or form, ever. I wouldn't suggest doing this either, because as Goddard's law says, when a measure becomes a target, it ceases to be a good measure. So there's other Python tools as well, for example, Vultr, which can help you find dead code. When I use this, I found it to be quite annoying, which is why I don't talk about it. I've not really covered any paid tools or services like Courtesy, Landscape.io, or SonarQube. You might want to consider these yourself. You can, of course, automate your own checks. So checks that you might do manually on your own project, you might consider automating those, so you just don't have to do them. For example, the two examples here, you might want to check that the upgrade and downgrade database migrations always work in both directions. But you might want to check that new dependencies that are added are pinned to a particular version. So I missed out how you can write plugins to things like Flake or Pilot or pre-commit, something which I'll talk about later. I've also not covered non-Python parts of the code base. I was surprised that there's a massive wealth of tools that are available. For example, I found both of these tools to be very useful. Had a link to check Docker files or shell check to check bash scripts. The output of these was very fascinating to me because I wasn't an expert in either of those areas at the time. And I've not talked about more comprehensive all-in-one tools like Prospector. For reasons including that they're more complex, they're harder to set up, and most importantly, they're harder to integrate into everyone's workflows. So how can you do that exactly? Integrate into your workflow. What are the different places that tools can slot into workflows? In my opinion, the best place for a tool is within your editor. Incorporating tools directly where you're editing your code gives you the fastest and most seamless feedback, to the extent where you might not even realize that a linter was running. I want to show 2 examples which demonstrate seamless integration. The first is where the editor, or the plugin to the editor, can fix your code for you. So here, I configured Sublime Text with the SuBlack plugin, which executes black whenever I save the file. So this reformats the code immediately, and so you can see what everyone else will actually be reading later. It's harder, or not really currently possible at all, to automatically fix errors with non-code style linters. For those kinds of warnings, unobtrusive hinting within the IDE is an excellent way to clearly bring the error to your attention without getting in the way of what you are trying to actually do. It's the same as having spell check when writing, and often this is how it's shown in your editor as an underline. This is great because you don't have to go back and forth with tests, running tools, or going back and from continuous integration output to fix things manually yourself. Support across editors varies considerably, but the most common tools are usually supported either directly in the editor or with a plugin. The ability to pick up project-specific settings also varies. I'll give 2 examples. So with editor config files, which I mentioned earlier, a lot of IDEs can pick those up automatically, or there's plugins available for your text editor if it doesn't come built in. So that's great. It makes it very easy for a user to use on any project if the editor config file is committed into the repository. Another example might be with IntelliJ, where IntelliJ picks up JavaScript's ESLint file inside the project and automatically configures the IDE based on that ESLint configuration file. There's one other thing that could be an issue with using the tools within the editor. Other people may not have configured their editors, and they're under no obligation to actually fix what the editor is telling them to do. Which was actually also a good point earlier. So in this example, you can see how PyCharm has unobtrusive hinting that the big number variable is not being used. It's probably because the function is probably meant to return big number rather than number. This 3-line try, for example. The next best place to use these tools is when you are committing code. I would recommend this for collaborative projects. So in this 2-line contrived example, we're just importing 2 random standard libraries, and then we're committing them, and then pre-commit was set up to run, and so I've shown the output of the pre-commit hooks. So one of the hooks is to trim trailing white space automatically, and that one passes just fine, probably because I had configured my editor with editor config. Later down, you can see the use of ISOR, and ISOR actually fails. And it fails because O comes before R in the alphabet. So as the output shows, the files are modified by this hook, so that means ISOR actually fixed the file for you. So if you just try to commit again, it will succeed. So this is easy to use. It requires minimal effort on your part. Pre-commit is a good way to have these hooks run for everyone on your team. However, there's a limit to how many hooks you can actually put here, because otherwise committing will take forever and you're actually getting in the way of people's workflows. For example, you might not want to add pylint because it's slow. The final place for these tools to run is the continuous integration pipeline, where pull requests are created. This is where code review from other people takes place, and ideally by this point, most or all of the low-hanging fruit has been caught by automated tools that were run before the pull request was created. The most common method might be to separately view the errors on the failing build away from the pull request itself. For example, you might go to Jenkins, or to Shippable, or to CodeFresh, and read the terminal output there. It just takes longer, and you have to match up the error to the actual code in your editor. An improvement to this might be where the continuous integration tool can comment on the pull request itself, like a normal reviewer could. There's no need to hunt down the errors, they're right there, and it's much easier to match up with your code because you can see the context right there on the pull request. So how do you actually add these new tools practically? For example, if you want to do it tomorrow. They can be difficult, especially on a large, old project. Running a tool like Pilot can output so many errors at first that you can just be in deep despair at the fact that of what you actually have to do. There's three main methods that you could use. When using a tool like Black that actually edits your code, you can nuke your entire code base so that it fixes everything for you. Rather than go into the specific details on how to do this effectively, I've linked to an article by one of my former colleagues who did it on a large code base, where he describes the challenges and solutions that they faced. The second technique is to apply the tools only on new code. So pre-commit is a great way to do this. Yeah, it's got a lot of the infrastructure set up already for you to do it. The final trick is to divide and conquer, either by the files and the modules, so you're only checking particular files off first, or by the types of errors that the tool can check, so you only enable particular errors to get started with. And then over time, you can check more files or check more error codes, so you can just spread out the pain. Okay, so the conclusion. Putting everything together, this is what I would do for code reviews in order to automate them most effectively. So I configure my IDE or text editor with linting tools to give me immediate but discrete feedback. I would use editor config, Black, and ISO because they're so easy to set up. I would use pipelakes because it will not give you any false positives. You can trust the tool. I would use pre-commit, especially if you're working with other people. It makes it much easier for them to set up the same kinds of checks. I would use safety and maybe Bandit to start checking security issues. Safety in particular is OPFM check is a great tool. It's also very easy to use. Then I would start looking at non-Python files in the code base. There's other low-hanging fruit that you can just that you can grab. Checking Docker files or checking shell scripts, for example, as previously mentioned. Those tools are quite easy to use as well. And then I'd also implement continuous integration when you're working with more people that integrates properly with pull requests. So it posts comments onto the pull request. I think that's quite neat. Finally, if you decide that you actually like pain, I would implement Pilot. So this is how I would automate code review to save time and energy, taking care to save time and energy when I'm doing automation itself. Thank you.
Thank you very much, Q. There is time for questions, so if you have got a question, please put your hand up. And can I just remind you that a question must be a question and not a statement or an advertisement. Anybody got anything they'd like to ask?
Thank you for the talk. You mentioned a bit about CI bots and posting on code reviews. You got any suggestions or recommendations for how to set that up? Or like resources that you know are useful for people?
So how to set up bots that post on pull requests. So one good tool that you could use with GitHub is Courtesy. That one is quite configurable, unfortunately. And it runs Python and it can post a lot of different comments. I once tried to set up something with Jenkins where it would post comments onto Bitbucket, but I basically just gave up on that.
Anyone else? This is just to keep me fit, I think.
A quick question about the black you have mentioned there. Is it possible that the auto-formatting that black does actually breaks the code itself? Like it produces code that is broken after it automatically fixes it?
So will black break your code once it rewrites it? No, black won't break your code. And it's been run on multiple large code bases before. It has a couple of things that it does. One is it has a slow mode where it has additional checks. I think this is enabled by default, so you have to disable it if you want it to run fast. And there is no second one, that was it.
Time for one final question, if there is one.
Of your list of advice, if you were going to just do one thing and make it a regular practice, which one would that be?
If I could only pick one thing out of this list and do it regularly, I would pick the first one, which is to configure your IDE. I'd pick that one because it's the easiest. Well, it might not be easy to actually set it up, but once it's going, it's the most unobtrusive. It's not going to get in your way, and you won't be wasting time.
Let's just thank you once again.